Look up tonight, because a messenger from another star is sweeping through our solar system. Its name is Comet 3I ATLAS, and it was born more than 7 billion years ago, long before Earth even existed. This is the third interstellar visitor we've ever detected, and the second interstellar comet. In the next 10 minutes, you'll discover what makes 3I Atlas so special, how it compares to the first two wanderers, Oumuamua and Borisov, and why astronomers are absolutely glued to their telescopes. Let's rewind to October 2017. A small, fast-moving blur appeared on images taken by the Pan-STARRS telescope in Hawaii. Astronomer Robert Wurick quickly realized its orbit was impossible for something from our neighborhood. The object had come from outside the solar system. It was designated 1I Oumuamua, which is Hawaiian for a scout from distant lands arriving first, and it officially became humanity's first known interstellar guest. But Oumuamua was bizarre. Radar showed a strange, cigar-like shape, maybe up to 400 meters long, that's 10 times longer than it is wide, far more stretched than any asteroid or comet from our own solar system. As it tumbled through space, its brightness varied by a factor of 10 in less than 8 hours, hinting at a chaotic, maybe even violent, past. Spectroscopy revealed a reddish surface, the result of being baked by cosmic rays for over 100 million years. The object contained rock and possibly metal, but there was no telltale water, ice, or dust that we expect from a comet. In other words, Oumuamua looked more like an alien shard than a traditional fuzzy comet. It whipped past the sun at a distance of just 38 million kilometers, that's closer than Mercury, then accelerated away, never to return. The data collected during its brief visit gave scientists a first glimpse at how other planetary systems might form and eject their building blocks across the galaxy. Then, barely 2 years later, on August 30th, 2019, Crimean amateur astronomer Gennady Borisov spotted a faint smudge near the constellation Cancer. Follow-up images proved that this object, too, originated from among the stars. Named 2I Borisov, it became the first confirmed interstellar comet and the second interstellar body we'd ever seen. Unlike the strange Oumuamua, Borisov behaved like a classic comet. Photos from the Hubble Space Telescope showed a bright nucleus shrouded in a spherical cloud of dust, and this thing was moving. The comet's speed was an incredible 177,000 kilometers per hour, fast enough to cross the Atlantic Ocean in just 20 seconds. Analysis indicated its nucleus was a loose clump of ice and dust grains, probably older than our own solar system. As Borisov skirted the sun, frozen gases on its surface vaporized, releasing a tail that stretched for hundreds of thousands of kilometers, an ephemeral bridge connecting our star to another far away. It was a beautiful, textbook example of a comet, just from a different cosmic address. And now, fresh on the scene, comes Comet 3I ATLAS. It was discovered by the Asteroid Terrestrial Impact Last Alert System Atlas, for short. This new visitor reached perihelion, its closest point to the Sun, on October 29, 2025. For weeks, it remained hidden behind the Sun's glare, but its orbital calculations confirmed its extrasolar origin. It was another traveler from deep space. Hubble observations from July 2025 managed to pin down the frozen heart of 3I Atlas. It's a chunk of rock and ice, roughly 300 meters across, wrapped in a hazy halo about 5.6 kilometers in diameter. Those dimensions place it right in the middle, somewhere between the cigar-shaped Oumuamua and the big fluffball Borisov. It's like a hybrid of our first two visitors. Even more exciting, chemical spectra show carbon-based molecules boiling off its surface. These are similar to the molecules we see in comets from our own Oort cloud, which suggests that the basic chemistry of starbirth might be universal across the galaxy. In short, 3I Atlas is a time capsule from a planetary system that may have died long before Earth even formed. It's a priceless piece of cosmic history delivered right to our doorstep. So, with this cosmic wanderer passing by, should we be worried? Happily, no. The comet's trajectory will carry it no closer than 270 million kilometers from Earth. That's roughly twice the distance between our planet and the Sun. This gap is far too wide to affect our satellites, communications, or even the tides. We're perfectly safe. Professional observatories will continue monitoring the visitor through December 2025, when it emerges into darker skies, making it easier to study. For all you amateur astronomers out there, telescopes larger than 20 centimeters might be able to pick it up as a faint, fuzzy smudge, but the comet will never become bright enough to see with the naked eye. So, what have we learned from these three incredible wanderers? First, interstellar objects are not a fluke. They are cruising through our solar system on a regular basis. We just needed the right tools to start spotting them. Second, they come in different flavors. We've seen rocky shards like Oumuamua, dusty ice balls like Borisov, and now hybrids like 3I Atlas. This hints at the diverse conditions in their home systems. It's like getting soil samples from different continents, but on a galactic scale. And third, their very presence proves that planetary formation is a messy, chaotic process. Young stars kick out trillions of fragments, asteroids, comets, and planetary building blocks. Some of these fragments drift for eons through interstellar space until gravity nudges them toward a new star like ours. Every single visitor is a free sample of exoplanetary material, no spacecraft required. The future of this field is incredibly bright. Upcoming telescopes like the Vera Rubin Observatory, ESA's Comet Interceptor mission, and NASA SNEO Surveyor will boost our detection rates from one every few years to potentially one every few months. Within the next decade, we might greet an interstellar visitor large enough and predictable enough for a spacecraft to perform a flyby mission, transforming astronomy from a passive, observational science into an active, interstellar one. Until that day arrives, Comet 3I Atlas continues its lonely march back toward the void. In the grand tapestry of the cosmos, our solar system is merely a roadside rest stop, and we are the curious travelers who were lucky enough to pause long enough to say hello. Keep your eyes on the sky, and thank you for joining this quick tour of our interstellar tourists. If you learned something new and feel a little more connected to the cosmos, share this video with a fellow space fan. May your own journey among the stars be just as adventurous.